All right. I believe that's Rick Springfield, in case you're curious. I'm not actually too sure myself there. Anyway, so composite area. All right. So the whole idea here is we're applying our knowledge of our shapes. So if we look, we got here. We want to use 3.14 for your pi here. We want to find the area of the shaded region. Now the big thing here is with shaded region is that they are subtraction problems. Take the entire shape, which is the circle, the large circle, all right, and then subtract out what you don't want, which here in this case is the smaller circle. So we are going to use pi times radius squared because it is the area of our circle. Our larger circle, if we start here, goes out 1, a 2, a 3. There's a radius of 3. All right, so that's going to give me 9 pi. All right, minus, and again, the area of the smaller circle. So the radius here is a 1 and then a 2. So it's going to be pi times 2 squared. Well, 2 squared is 4, so it's going to be 4 pi. Now, if you notice here, I've held off on using my 3.14 because it's going to make my life rather easier. What's 9 pi minus 4 pi? Well, it's 5 pi. All right. Remember, it's a variable, so it's just like as if it was an x. Now is when I can go ahead and multiply it times the 3.14. I'm avoiding all the usage of all those decimals from before, and it's something that's going to clean things up. So that's one of the big things that you can end up using, all right, in order to figure things out and make your life easier there. Don't put in the pi until the very end, especially if you're doing some addition or subtraction, all right. Let's see what we got here. We got a yard, all right, so with the shaded section indicating grassy areas and the unshaded sections including the paved areas. Find the area of the space covered by grass there. Okay, so let's see here. All right, so in this particular case, it's always going to be the entire shape, which is your large rectangle. And then we're going to take out what we don't want. Now, this is where it gets a little bit interesting, all right? Because, I don't want this, all right? What that's going to do here is, you know what? We're going to kind of make it into two separate problems. I'm just going to find this region first. I think this is the better way of going about it. I'm just going to do this first. So that's going to be that large rectangle, all right, minus the smaller rectangle. Actually, I guess we'll call it the medium-sized rectangle. So let's see here. So units of measurement, looks like we're dealing with halves here. So we're at a half. So let's see here. This is 1, 2 and a half. So 2 and a half and a half, that makes a 3. And then if we go left to right, we're going 1, 2 and a half, 3 and a half, and so that makes it a 4. So it's a 3 by 4. All right. Looks bad, but it's not. So the area of that large rectangle, 3 times 4, that gives me 12. The middle-sized rectangle, it's a 1, a 2, a 3. All right. So that's how it is a 3. And then how tall is it? It's a 1, it's a 2. So 3 times 2, yeah, that's 6. So 12 minus 6. Okay, so that gives me 6. So which means this particular shade, this region right here, has an area of 6. I'm going to hold on to that. Now what I'm going to do is I'm going to come over here and define this particular amount. All right. Again, now I can do this rectangle minus the small one. So I'm going to do the medium-sized rectangle minus the smaller rectangle that we've got. We've already got this information. It's a 6. All right, minus, and let's see here. All right, so this is where I'm not as thrilled with this particular problem. Test-wise, we have to give you something a little bit more specific. We're going to make this a quarter, okay? And again, typically we can't estimate. It's not allowed. Again, we do know we've got an entire unit of a 1 that is there. So if we look at this, it looks like we're at a half and a half, so that makes it a 1. If we're going left to right here, we're at a quarter and a quarter, so that's going to make a half of the amount. Again, not thrilled with that particular setup. We would give you crisper and cleaner numbers that are there. So 1 times a half. All right, so if I do 1 times a half, well, we get a half. So the area there is 5.5. 5.5 units squared. So kind of a twofer problem there. Again, couldn't do everything at once, but I was able to find this area here. All right, and wait a second. The yard is shown with the shaded section, including the grassy areas. So the yard is shown with the shaded section. So this is the grassy area. The unshaded section is the paved. Find the area of the space covered with grass. Wait a second, what have I done wrong here? Yeah, I didn't need any of this that's there, all right? So that's the kind of stuff, yeah. So again, problems wise here is don't always fall in love with, woo, I got to always subtract the amounts that we've got here. No, 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 no. They just wanted the grass here. So you already shown the section indicating grass here. The unshaded sections are the paved area. Find the area. We can just do this and we are done with it. There was no need to go about. I could have just right away done the 2 and then 1, 2, 3 by this. Yeah, I didn't. So again, the answer is correct here, and sometimes you're going to find that. Sometimes you do a little bit more than what you needed to get to the answer. So kind of stop and think about that one a little bit, and kind of make sure that made sense there. I know, like I said, I didn't see that at first, but that's okay. That's normal for you to kind of see something and then go back, read the question, be like, oh my goodness, I can't believe I did that there. All right. Yep. Perry the Platypus here. Yes, right by my side, helping out there. All right. Let's see what we got next here. You ready for this next one there? Okay, so here's the thing, all right? The area of the figure of a rectangle. Now, this is where we get interesting. Oh my goodness here, people. You ready for this? We do know it's a semicircle. So what I'm going to do is I'm actually going to draw that in. The reason why that's so important is, what this part is, how long is this line? Well, it's the opposite side of the rectangle, so it is a 4, which means it's a 4 off the rectangle, which means, what's the radius going to be? The rate 2, because it's got to be half the amount. Exactly. Now, if the entire distance is 7.5, and from here to here is 2, that means the remaining distance must be, 5 5/10. So now I can do area of the rectangle plus the semicircle. All right. Area of the rectangle, I'm going to do 5 5/10. We're going to multiply it times 4. All right. When you do 5 5/10 times 4, and then you can use some mental math there if you want. 20, half of 4 is 2, 22. Yeah, 22. All right. Plus the half circle. So a half of times pi times radius squared. All right, so let's plug in some information. A half, 3.14, and again, I plugged it in because I don't have any other pi's to be using there, and the radius squared, so 2 squared is 4. All right, clean up things, make it easier. Half of 4 is 2, but again, you can just punch that all in your calculator at once if you want, but I'd rather do half of 4 and get 2, and then do 2 times 3.14, all right? So we can add this together, 28 and 2800 meters squared. Okay, quality problem there. Again, shapes that are up against each other, that's the connection that we're looking for. All right, let's see here. Find the area of the shaded region. We know from here to here is a 14, so you can see I am going to do triangle and add on the half circle. So the big thing here is this is a 14. Because it's a triangle, I need base and height. There's my right angle, so I've got my base. I need my height. Now here's the thing. What part of the semicircle is this? That's the radius. Yeah, so if you'd like to, that's the center. So how big is it from there to there? Well, the radius is 4, and that means the entire diameter. Oh, there's the diameter. So the entire diameter is 8. Yeah. So it's a half times 14 times 8. Half of 14 is 7. 7 times 8, 56. So minus the half circle. So 1/2 times pi times the radius squared. Again, notice. I'm always writing that formula down first. It's going to get my thoughts focused so I can keep myself on track. A half times 3.14. The radius is, it's 4. All right. So 4 squared is 16. What's half of 16? It's 8. So it's 8 times 3.14. So if I do 8 times 3.14, all right, 8 times 3.14, that gives me the 25 and 1200ths. And then I can subtract that with the 56, 25 and 1200ths. I could have just typed it all in my calculator at once. Again, it will do the order of operations for me, which is nice of the calculator. 30 and 88 hundredths centimeters squared. So the big thing that we're looking at here is the overlapping of the shapes and the sides that they share. Okay, so here we go. Find the area of the shaded region. Okay, so do you see, I think it's going to be a square, yeah, 20 by 20. And then we're going to take out the 3 different triangles. That triangle, all right, the triangle that's up top, all right, and then the little guy that's in the corner. Now, we actually solved this problem yesterday. All right, we saw it on a grid. Now they're actually giving us numbers that we're going to have to figure things out. So first of all, the square. All right, 20 times 20. All right, I'm going to get 400 there. All right, the triangle, the first one here. All right, so that's going to be a half times the base times the height. So a half times, well, I can see the height is 20 that's there, and I can plug it in again. The order doesn't make a difference. I know how far it's from left to right. Well, if the entire amount's 20, and you've used up 8, yeah, it should be 12. All right. Now again, half of 20, 10. 10 times 12, yeah, 120. All right, so we're going to subtract away 120. That's there. Let's come up here to this guy. All right, I see that's a 20. All right, if that's a 6, that's going to make this a 14. All right, so same thing as before, a half times and then 20 times 14. Half of 20 is 10. 10 times 14, 140. All right, and then we got to take away the little guy that's there. All right, there I've got the information, a half of 8 times 6. Half of 8 is 4. 4 times 6 is 20. So this is one of those problems that we actually really like because the math behind it is pretty straightforward, especially if you make those recognitions. And those are recognitions that we want you to end up making there. So 400 minus 120 minus 140 minus 24, and I end up with 116. So 116 centimeters squared. All right. Here's what I want you to do. I want you to try the next problem that you've got there. All right. I struggled with this one the first time I saw it, and in fact, I'd have someone kind of give me a hint. So this is one of the things with your visual shapes is sometimes it can get a little bit frustrating. All right. I know. Don't feel bad about it. All right. Give it a shot. See what happens. All right. And then make sure in class tomorrow you say, hey, can you show me how to do problem number 3 or exercise number 3? I didn't see it there. All right. Absolutely, I promise.